first we're going to review circumference and area, and then we'll do some applications of those. So remember that circumference of a circle is the distance around the circle, and that is given by the equation c equals 2 pi r, or c equals pi times d. Remember, r is your radius, d is your diameter. So you could use either radius or diameter to find the circumference, depending on what you are given. For area, area is the amount of inside the circle, so that's given by pi r squared. So that should look familiar to you all. All right, so now we're going to use that to find the diameter of this first circle. Notice that they gave us c, which is the circumference. So since I'm trying to find diameter, I'm going to use the circumference formula that has diameter in it. Now I'm just going to fill in 58 for c, and I'm going to solve for d by dividing both sides by pi. So if I do that, I get my diameter is 18.46. Over here, it also wants me to find the diameter, but now I'm given the area. Remember, the area formula only has radius in it, so I have to first find the radius and then double that for the diameter. So if I fill in what I have for area, I have 125 equals pi r squared. I'm going to do the same thing and divide both sides by pi. So when I do that, that gives me a really long decimal, 39.7887. You really don't want to round that. I'm just rounding it so I can write it. You want to keep that in your calculator. That way when you do the next step, we're going to square root, we get a more accurate answer. So my radius is 6.31. Now I'm going to take this answer and double it. I want to double that. That's going to give me my diameter. So if I do that, my diameter equals 12.62. So we worked backwards with those formulas. Another application we can use is revolutions of a circle. So we have these two tires from a tricycle, and it's asking us to figure out how many times do these tires revolve. Remember, a revolution means one time around. All right, so how many times do they go around in order to travel 250 feet? And each of these, they tell us that the diameter, here this is our diameter, 20 inches, and over here this is our diameter, 16 inches. Okay, something to keep in mind is that one revolution, I'm going to abbreviate that with rev. One revolution is equal to the circumference of the circle, because if I go all the way around the circle, if that wheel travels all the way around, that's one revolution. That means the edge of the circle, so that's one circumference. So it's really asking us how many circumferences can we fit in 250 feet. The other thing we need to address is that this is in feet and these are in inches. So we need to change feet into inches. So 250 feet, that's going to be way more in inches. So I need to multiply 250 feet by 12, and that'll give me 3,000 inches. So if you want to write down how we did that, we just multiplied by 12 to get 3,000. So I really want to find out the circumference of each circle first, and then we're going to see how many of those we can fit into 3,000 inches. So on this first one, my circumference is going to be pi times d, pi times 20. So I'm going to write that as 20 pi. And then over in the small one, my circumference is 16 times pi. I'm just doing the diameter times pi. So for the first one, I'm going to take 3,000 inches and divide it by 20 pi inches. Remember, that's one revolution. So that'll tell me how many revolutions we get, and that's going to give me about 47.8. It says to round to one decimal place. So I'm going to get 47.8 revolutions. And then over here, on the smaller one, I'm going to take the 3,000 and divide by 16 pi. And that's going to give me about 59.7 revolutions. And that makes sense, right? Because the smaller one should have to spin more to travel the same amount of distance as that bigger one. Another application we can do with circumference and area is arc length and area of a sector. Really, if you think about arc length, that we've been talking about arcs. This is an arc, let's say arc AB. And if I want to know how long is that, if I was traveling along that edge of that arc, how long would I be traveling? And it's not going to be the whole entire edge of the circle. Remember, the whole entire edge of the circle is circumference. And that's why in our formula we have here, that's the circumference C. But it's only going to be a portion of that, a fraction of that. So that fraction is given by however many degrees that arc is, so that's the measure of AB, divided by the total number of degrees in the whole circle. So anytime we're going to do arc length, we're going to do that fraction times the circumference. Very similarly, we can do the area of the sector. Remember, that's how much area does this pie slice take up. Now, it's not the whole area of the circle, it's just a fraction of it. So notice that we are using the area of a circle, that's the A, but we're only doing a fraction times it. And notice it's the same fraction as the arc length fraction. We're going to take the degrees of our arc length of the arc and divide it by 360. So let's do a few examples. Right in number 4, first thing I'm going to do is arc length. They want us to do arc length and area of the sector. So we're going to do both of those. So I'm going to abbreviate arc length with AL. I'm going to do my fraction. So that's this angle right here is 54 degrees out of 360. And I'm multiplying by the circumference, which is 2 pi r. Here my r is 5. And if I do that, that gives me in my calculator 3 pi over 2. And I really want an approximation, so let's do 4.7. That comes out to be about 4.7 for the arc length. Remember, that's this distance right here. Now for the sector, I'm going to abbreviate that area of a sector, AS. I'm going to do 54 degrees divided by 360 degrees. Remember, that's the fraction. And I'm going to multiply by the area, since I'm doing area of a sector. So that's pi r squared. And when I put that in my calculator, I get 15 pi over 4. And then that gives me about 11.8. So that's one example. Try to do examples 5 and 6 on your own. Pause the video. I will do the same. And then when you come back, you can check your answers. Okay, so you can check your answers. If you need more time to do that, please pause the video. I'm going to move on to the back. So in these problems, these involve a little bit more thinking. We're trying to find the area of this shaded region. So notice that this is a rectangle, and the only part that's not shaded are these white areas. So it's like 2 sectors. So my plan for this is I'm going to take the area of a rectangle and subtract 2 areas of the sector. Okay? So the area of the rectangle is pretty easy to find. It's just base times height. So that's 12 times 8, which is 96. The other part, let's figure that out. We were just talking about area of a sector, and they gave us this angle as 108. So the area of the sector is 108 divided by 360 times, oh, now we need the radius. Ooh, they didn't give us the radius, so what do? Well, we know that all the way across, if I go from top to bottom of that circle, that's my diameter. And that is also 8. They gave us that is 8. So half of that will be the radius. So the radius is actually 4. So when I'm doing my area of the sector formula, I'm going to do pi times radius squared, so I'm going to do pi times 4 squared. So if I plug that into the calculator, that gives me 24 pi over 5, which is about, well, I didn't get that decimal, I doubled it first. So if I double that, that's going to be 2 times that. That's going to give me 48 pi over 5, which is about 30.2. Okay, so that's what I'm going to be subtracting up here. The 2 area of the sectors. So if I subtract that, I get a total of, that gives me a total of 65.8. All right, so this next one, number 6, we have to find the radius, and we're given the area of the sector. So remember, area of the sector is going to be the angle measure over 360, which is 85 over 360, and it's times pi r squared. And that answer, they tell us, is 47.5. So we're going to be solving for radius now. So if I multiply 85 over 360 times pi, that gives me a decimal, which is 0.7417 r squared. I'm going to divide by that decimal, and that gives me about 64, which is nice. So if I square root that, my radius is 8, which is C. So on this next multiple choice, they're giving us the diameter, and we have to find the area. So all we have to do is take half of the diameter, so the radius would be 3.5, and we're just doing the area formula, pi times 3.5 squared. So if you do that, that gives you 38.48, which is E. That one wasn't bad, was it? All right, so the next one, find the radius of the circle with an area of 66.5. So this is very similar to the one on the front, except they don't give us a diagram with it. So 66.5 is equal to the area formula, pi r squared. Divide both sides by pi, and you get 21.17. And then you want to take the square root, and you get 4.6. And that is answer choice D. All right, this next one is interesting. So we're trying to find the perimeter of this shape. So if we look at that, that's 3, and then across the top, that's going to be 8, just like the bottom. So this will be another 3, and then this is 3, this is 3, this is 8. Now the part that's weird is this curved part, but do you see how these two curved parts make up the circumference of a circle? So we're basically going to be doing the 8 plus the 8, plus the 4 3s, so that would be 3 plus 3 plus 3 plus 3. And then I'm going to add the circumference of this circle. Now, the circumference of the circle, we need either the radius or the diameter. So how much is that? Well, they tell us that this whole height is 12. So if these two add up to be 6, then the middle there has to be 6. So our circumference has to be pi times my diameter, which is 6. So if I add all of those up, that should give me a total of 46.85, which is D. We are going to skip number 7 for right now. Number 5, down here, is talking about a birthday cake cut into 16 equal pieces. So that makes me hungry for cake. So we've got this circle, and we're cutting into 16 equal pieces. Now my drawing may not be very exact. So that's 8, and then we got to slice each of those in half. All right, so we got 16 equal pieces, and we want to figure out what is the area of just one of those. They also tell us that the diameter is 14, so that means that the radius is 7. So if we're doing the area, we need to know what is the angle measure. So I have to know what is the angle measure of just one little piece here. So we know the total is 360, and it's divided equally into 16 equal pieces. So I'm going to divide 360 divided by 16. It's like we're finding the central angle. So that gives me 22.5. So this little angle right here is 22.5. So that's what I'm going to use in my formula. So I'm going to do area of the sector is 22.5 over 360 times pi r squared. So pi times 7 squared. So if I put all of that into my calculator, that gives me about 9.62, which is choice E. And then our last one, we are given the arc length. That's kind of weird. You may not, it's kind of tricky to see that, but this is not degrees, this is an arc length. That's how long that is. And then this is the degree measure, 75 degrees. They want us to find the radius. So we're just going to use our 75 over 360 times 2 pi r, since that's arc length formula, and we know that the total is 32.3, and we're solving this for r. So if I multiply all of this stuff together, that's going to give me 1.309, and I'm going to divide by that number, and I get the radius is 24.7, which is A. So we've done multiple examples of how to use area and circumference